Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by Julie Tomei. That's right, it's the Julie and Elena show tonight, broadcasting live from Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. As a reminder, this is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at 2 a.m. UT, if that's more your speed. The York Universe production works in concert with our online public viewing program, run by the amazing Observatory team. Congratulations, team. They are running right now. So because it's in concert, that means that if you're listening to this broadcast live, you can join right now. It runs between the hours of 9 to 10 p.m. local Toronto time. All you have to do to join in the fun is go to yorku.ca/science/observatory and follow the links to OPV for online public viewing, or click on any link that says YouTube. That'll take you to our YouTube channel where the online public viewing is. That's right, it's Allan Carswell Observatory YouTube channel. So you can listen to this show and watch beautiful images as well as chat with our team. Our broadcast tonight is powered by and in partnership with Astronomy.fm, the voice of astronomy. If you have any questions or comments or ideas for shows, please send us an email at observe@yorku.ca. You can always connect with us on social media. We're over on Twitter at York Observatory and York Universe. And of course, we're on Instagram with York U Observatory and Facebook at Allan Carswell Obs. All of our programs are free, but if you would like to make a donation or buy some really cool swag, you can see that website from before, yorku.ca/science/observatory. Our crew is monitoring the chat room for questions and posting content and there to answer your questions. So feel free to join in on OPV on our YouTube channel or get there through our website. It is actually looking like it might be clear weather tonight, and that means that if it does clear up, our crew will open up the 1-meter telescope and share the live images on YouTube with you. So that's if it's clear. So I have it on good authority. They're going to give it a try tonight. Good luck to our crew and fingers crossed for the cloudy weather. I hope that it clears enough for us to get some clear, nice views, maybe something bright. Anything nice and bright where you are, Julie?
Think the moon.
That's always a good one. Always a good one.
I am indoors and the sky is outdoors, so.
Well, in Toronto, of course, we do have a lot of weather to worry about. We've had just a terribly cloudy and rainy and all kinds of stuff summer. But if it does clear up, there's some great stuff to look out for, especially if it's a little bit, just a little bit clearer. You can always look up and look for planets. The moon is rising, so it's a nice big full moon. Not completely full, it's 99%, I think, but pretty close to full. And of course, there's planets, Mars, Mercury going down right now, so that's going to be a little bit harder to catch. If you've got a clear view to the west, Mars is awesome, and I mention that because it is relevant to tonight's episode.
We'd be talking a lot of Mars tonight.
Yes, and unfortunately, it will be setting quite soon, so it's probably going to go down before we get through this episode. You do also have a little bit of an obstruction tonight because we are being Starlinked. So if you are trying to observe anything in the realm of Arcturus off through Vega, there's actually a Starlink cluster passing overhead this evening, which means that you'll see a line of lights going across the sky, little tiny points in a straight line going sort of towards the east, I believe. But yes, that's the famous, the now infamous Starlink satellites that are getting getting in all kinds of people's view.
2008 and operated until November 2nd, 2008, which made it operational on the surface of Mars for 157 sols, or approximately 161 days. The instruments were used to assess the local habitability and to research the history of water on Mars. This was a multi-agency program that was led by the Lunar and Planetary Laboratory at the University of Arizona, with project management by the Jet Propulsion Laboratory. There were academic and industrial partners, including universities in the US, in Canada, Switzerland, Denmark, Germany, the UK, NASA, the Canadian Space Agency, the Finnish Meteorological Institute, Lockheed Martin, McDonnell Detweiler and Associates, in partnership with Optech Incorporated and other aerospace companies. This was NASA's first mission to Mars that was led by a public university. So because the CSA was involved, this one I think got, all Mars missions get quite a bit of attention, but this one got like extra attention here in Canada because there was a Canadian contribution. This was NASA's sixth successful landing on Mars from 7 attempts, and the first in the Mars polar region. The lander completed its mission in August 2008 and made the last brief communication with Earth November 2nd as the available solar power dropped with the onset of Martian winter. The mission was declared concluded on November 10th after engineers were unable to recontact the craft. JPL declared the lander dead after unsuccessful attempts to contact the lander by Mars Odyssey up to and past the Martian summer solstice in May of 2010. It was considered a successful mission because it completed all its planned science experiments and observations. The mission had two goals: to study the geological history of water, the key to unlocking the story of past climate change on Mars, and to evaluate the past or potential planetary habitability in the ice-soil boundary. The primary mission was scheduled for 90 sols, and that was exceeded by a bit over 2 months. There was some hope that it would survive into the Martian winter so that Phoenix could witness some polar ice developing around it, perhaps up to 1 meter or 3 feet of solid carbon dioxide ice could have appeared. Unfortunately, that wasn't meant to be. The scientific payload included a robotic arm and camera, a surface stereo imager, a thermal and evolved gas analyzer, the Mars descent imager, and the microscopy, electrochemistry, and conductivity analyzer, which was an instrument package that contained a sample wheel and translation stage, an optical microscope, an atomic force microscope, the wet chemistry lab, the thermal and electrical conductivity probe, and a meteorological station. So lots of results from this mission. As far as landscape, the polar landscape is very different from the other Martian landscapes that we had visited before. The rocks are small, the landscape flat. There were polygon shapes on the landscape, likely shaped by the freeze-thaw cycle. No ripples or dunes. Ice was present a few inches below the surface in the center of the polygons and along the edges. And the exposed ice would sublimate. There were a few dust devils observed. Weather. Snow was observed falling from cirrus clouds that would have likely been composed of water ice. Winds ranged from 11 to 58 kilometers per hour and averaged 36 kilometers per hour, which sounds like a lot by Earth standards, but that doesn't exert much force because the atmosphere of Mars is so thin, it's less than 1% that of Earth. And the temperatures ranged between minus 19.6 degrees Celsius to minus 97.7 degrees Celsius. And for our friends who prefer Fahrenheit, that's a range of minus 3.3 to minus 143.9. Climate cycle, so they were looking for like what had happened in the past. They found some calcium carbonate in the Martian soil, which led scientists to think that the site had been wet or damp in the geological past. During seasonal or longer periods, diurnal cycles, during seasonal or longer period diurnal cycles, water may have been present as thin films. And a lot of surface chemistry was done as well. So the soil was found to be moderately alkaline, and the overall salinity modest, which is considered benign from the standpoint of biology. There was the presence of bound water and carbon dioxide, as well as chloride, bicarbonate, magnesium, sodium, potassium, calcium, and sulfate were found, and evidence suggests a severely arid environment with minimal or no liquid water interaction at the poles.
Great stuff.
So much to read about this mission.
Oh yeah, well, and it's even more interesting than, I mean, I think we'd need a whole episode just on this one if we were going to do it really justice. But the Phoenix mission, as I say, what's in a name, one of the reasons this really, really captured people's imaginations, in kind of, I think, some of a similar vein to Hubble, is it was actually thought to have been destroyed, because it was based off of the Mars Odyssey orbiter. And the Mars Odyssey orbiter was an attempt at a polar lander that had happened before in 1999. It was going to go to the south pole of Mars, and it was going to be part of this whole polar exploration. And it was not a cheap endeavor. But it did have some problems, and the mission was basically a failure. It has a nice timeline of 1999. They were able to tell that it went into the atmosphere in December, but they could not regain any communication after quote unquote landing. So it probably crashed or something, but they finally declared it dead in 2000, which was a real loss because it would have been the first real polar lander. And this sort of a big deal, but they had a lot of components, because if you've ever seen testing of telescopes or anything that has gone into space, they always have this clean room somewhere where they've taken apart the components and they're testing it, and they end up with sort of a testing array. It was hugely exciting because it's like a second chance. So that was 2007, and it's a little bit of a funny timing, because I was actually in Arizona at the University of Arizona, spending a lot of time in their LPL lab exactly when these were not happening, which is, so the original one crashed and was declared dead in 2000, which was about the time I arrived, and the other one was launched in 2007. So I missed both the, I don't know, death announcement and the launch of the Phoenix. But I can tell you that in the 2000 to 2005, everyone was very, very excited about Phoenix. They had lots of stickers they were giving out at LPL, and the chance to go back to the pole and look at this ice that's just right there, like you barely even had to scratch the surface and you could see all kinds of stuff. This interesting chemistry just right there for the taking, for the grabbing, I guess. and it wasn't planned to live hugely long. So it's not, as you say, it's not incredibly disappointing that it didn't last for ages, but just in comparison to some of our other Mars missions, we've been quite spoiled because they very much outlived their lifetime.
Well, I complain about, minus 20 with a wind chill of minus 40. That's almost minus 100 degrees Celsius. Like,
oh, absolutely. And that's when you think we've seen some winters in Canada, but we've not seen anything like this, right? And that's at that kind of temperature, you get things like cold welding, where your metal pieces stop moving properly, and you have to worry about all kinds of weird stuff happening. So it's amazing that it got there, and finally with its great second chance. And there's some great pictures of its little the ice that you can just see just through the top of the red dust. So they just sort of scraped off the red dust, and there's ice right there. And of course, it wasn't all about just water ice, but also carbon dioxide ice, dry ice. And carbon dioxide ice can form at much lower pressures. So we think that where Phoenix landed, you would get carbon dioxide ice and water ice at different parts of the year. So you kind of understand a little bit about the strange Martian atmosphere. We think snow is bad here. At least it's not carbon dioxide snow. So,
put it in drinks. No, never put dry ice in drinks. Put it in water, and it does that cool foggy thing. I'm trying to find the silver lining.
I think you can put it in a drink if you have one of those protecty things, so that there's no chance of it coming into contact with humans, because like you do not want to ever ingest dry ice. It's very, very bad for you, but it's a great fog maker, and you can make ice cream with it. So there's some upsides for you. Although liquid nitrogen ice cream's better. So anyways.
I haven't had dry ice cream. I've had liquid nitrogen ice cream.
Yeah, and dry ice actually is great for some fog machines and haunted houses.
And making a comet.
Yeah, making a comet, exactly. Very good cometary behavior. So I figured I'd keep us on the Mars theme. I saw that Phoenix lander go up, and I thought, aha, I can find more Mars stuff that's happened. So Mars has a lot to do in this time of year in history. So I'm going to kind of stick to the same theme, but go up to 2020, which was the Mars Perseverance and Ingenuity launch. So this was landing on Mars in the 18th of February 2021, so about 2 years ago. And as of today, Perseverance and Ingenuity have been on Mars for 869 sols, or 893 total days, which is, 2 years, 163 days. So these two are kind of the latest and the greatest of the bunch, if you will. So Perseverance and Ingenuity were part of a hugely popular race to Mars that was happening, with lots of fun missions. But these ones in particular are kind of related to what we've been talking about with Phoenix, which is I'm trying to understand more about the Martian environment. And what we saw up at Phoenix with the poles was, of course, this strange behavior of two different kinds of ices, but also they had methane up there. And methane is not something that generally sticks around very well, so something has to produce it. And what's happening now is Perseverance and Ingenuity, they're looking at a totally different part of Mars. So they've been driving around all kinds of places. Gosh, I forget exactly how far they've driven, but I'm sure it's easily look upable. But they landed near Jezero crater. I hope I'm saying that right. And they've been driving around there ever since. So the rover is the the Perseverance, and it's got a small helicopter called Ingenuity. And this is really, really cool because, since it landed safely, this was the first big challenge. Of course, Curiosity kind of leading the way for this mission. Getting it down onto the surface, this was a large rover. It was kind of like, more small car sized than, very small car, but still more like a little car than a toy. So it had a substantial weight to it, and it's able to do a lot, and it's able to talk to its little helicopter. Its little helicopter can fly around, and you get all of a sudden aerial views of Mars. So this is our first extraplanetary flight, I suppose. I'm not sure how you'd classify it, because obviously in space we call that flight, but this is flight on another planet. And this is really cool because if you can fly around, you can survey a much, much larger area than you can if you're just walking. And anyone who's been in a plane knows all about that. So Perseverance has been going around looking at kind of ancient environments on Mars, looking at surface geological processes and history. The possibility of a past life on Mars has been the focus of many, many, many missions, because we can't see anything happening now, but earlier on in Mars's history, it would have been a warmer planet. It wouldn't have radiated so much of its heat out into space. There could have even been liquid water on the surface. And in that condition, maybe something did evolve and now it lives under the surface. And wouldn't that be cool to find out? So Perseverance has been driving around, and sort of Ingenuity helicopters has been sort of hopping forward before it. And this was a really, really exciting time. I remember this happening, and I think I'm pretty sure we did a special Teletube episode for the observatory. If we didn't, it was no, we must have, because this was a whole trio of Mars missions. We had this Perseverance Ingenuity, and there was the Emirates Mars mission with Hope, and the Tianwen-1 mission from China. And they were all trying to get out at the same time because, of course, Mars and Earth only line up every so often. So you want to try to get there when your distance between Mars and Earth is at a minimum, so you don't have to fly through space for so long. So this was really, really cool stuff, and it's still going. So you can still look up Perseverance and Ingenuity. You can get the latest and greatest details off of each one. They're still actively going right now. So Perseverance rover actually does have a full-scale engineering model available at one of the JPL Mars yards. And this is really cool because we talked about LPL and the University of Arizona and the Phoenix rover. Well, the reason why you would have a full-scale engineering model left behind is for testing, because you can't test the device once it's on the other planet, but you can test an identical one that you happen to have in your garage. So they actually have these Mars yards, which are landscapes usually somewhat deserty, in Arizona or I guess parts of California, and run by JPL or LPL. All kinds of great things. So they get these great pictures of Mars on Earth a little bit. So anyhow, the copy of Perseverance you actually can see at the JPL Mars yard if they're currently letting people see it. So you can actually see a copy of the real, a functional copy. And because we had Ingenuity, the helicopter, as well as Perseverance, the rover, we have pictures, very good pictures of both, because they can photograph each other, which is quite nice because you didn't have to do that old-fashioned rover selfie that you see with so many panoramas. So the landing site near Jezero Crater was thought to be a really, really high potential area for finding maybe traces of ancient life, lots of signs of riverbeds and things like that. And it's actually called the Octavia E. Butler landing site. It's named for the American science fiction author. And there's all kinds of great stuff. So I think that in order to prevent the the Ingenuity and Perseverance from taking over the whole episode, what I will say, which will lead me into kind of the next my next thing, is that the Perseverance rover is, among many other things and measurements and photography, it is actually taking samples of Mars rocks. So it's examining rocks on the surface, and it's collecting sample rocks in these little sample rock packs, and those can be returned at some future point to Earth. Yes. And that is actually something I'm going to talk about later, but this is ongoing. So the possible sample return, part 1, is actually being done right now. The rover is collecting them. And if you want to see this rover driving around on Mars, the great thing about this is we have the HiRISE camera operating right now on Mars. And this was also a very, very big thing in Arizona, let me tell you, in 2004. Everybody was talking about the HiRISE camera because it's a high-resolution imaging camera for Mars. It's on board the Mars Reconnaissance Orbiter, and it's been up since 2006. And this camera is so good, it can see the parachute from the Perseverance rover. So it's got, I think, 1 meter resolution. It's an incredible resolution on the surface. You can see the parachute. You can actually, in some cases, follow rover tracks. You can really get all kinds of great imaging from recent potential water activity like jets and geysers and cracks and crater edges. There's just too many good things. So if you want to follow along with this mission with real data, I definitely recommend the HiRISE image gallery to anybody who's interested. And of course, fingers crossed that the Perseverance and Ingenuity keep going for a long time. So I'll wrap that up there and talk about the sample return, I think, after your next object, Julie, right. Because otherwise we'll be on Perseverance way too long.
Sure. I will add that if you go to the Mars 2020 Perseverance rover website for NASA, you can find a map of all the driving around that Perseverance has done and all the flying around that Ingenuity has done. And it last drove, the latest drive was Yestersaal.
Exactly.
And it is at a grand total of 19.3 kilometers or 11.99 miles on the surface. It's got some nice high-res, like aerial imaging of the crater, and it's pretty cool. So, you know, if you're online and don't know what to do with yourself, go check that out.
Absolutely. And there's so many wonderful tools right now for Mars exploration, because NASA's done a really good job with their sort of outreach website. If you're poking around and you're on mars.nasa.gov anyways, the Mars exploration tool is also in there that has a 3D clickable Mars, which will show you, let you drag around. I think it's related to your tool, Julie. But you can go backwards and forwards in time and see where things are moving. So it's pretty fun. So yeah, there's some really, really great tools out there for sure. All right, so before we get too distracted, let's do a little something different, and then we'll go back to Mars for my last.
And now for something completely different.
It's still a launch. It's still a launch.
I guess. We are going to August 8th, 2007, and the launch of STS-118. This was a mission to the International Space Station flown by the Endeavour Space Shuttle. It landed back on Earth on August 21st, and it was the first flight of Endeavour since STS-113 in November of 2002, which was also the last successful shuttle flight before STS-107, which sadly culminated in the loss of the Columbia space shuttle. Columbia had originally been scheduled for this flight and for what would have been its 29th mission, and its what would have been its first and likely only visit to the International Space Station, mainly due to its heavier weight. The media focused heavily on a small puncture in the heat shield created by a piece of insulation foam that came off the external tank during liftoff, though the foam impact that ultimately destroyed Columbia caused more damage and was in a critical area. On August 31st, so 10 days after landing, NASA reported that the damaged tiles had been removed in the orbiter processing facility, and engineers had found no evidence of heat-related damage to the orbiter itself. So, phew. The crew included Canadian Space Agency astronaut Dr. Dave Williams on his second and last space flight. He completed 3 spacewalks during this mission and set 2 new records during his final EVA. He is the Canadian with the most spacewalks at 3 and ended the EVA with a total duration of 17 hours, 47 minutes of extra vehicular time. He was the second Canadian to lead an EVA and is one of 4 Canadian astronauts to have performed EVAs. The mission delivered and assembled the starboard S5 truss segment to the ISS, as well as the external stowage platform 3 and a replacement control moment gyroscope. The mission was also the final flight to include the Space Hab Logistics Single Module, which was a pressurized aluminum habitat that was carried inside the payload bay, had a capacity of 6,000 pounds, and carried a variety of cargo and research projects, including supply materials for the ISS. It returned cargo and different payload, like experiment payloads that had been installed in the International Space Station that had been launched in July of 2006. And some of those included material specimens that would be studied to determine the effects of long-term exposure to the environment of space. The mission marked the 150th crewed U.S. space launch, the 119th space shuttle flight, the 22nd International Space Station assembly mission, the 20th flight for Endeavour, the 94th post-Challenger mission, the 6th post-Columbia mission, and the first flight with the SSPTS, which apparently is pronounced SPITS, which is the Station-to-Station Power Transfer System.
Like SPITS, huh?
SPITS, SSPTS. The shuttle-to-shuttle power transfer system, and that allowed a docked space shuttle to make use of power provided by the International Space Station's solar arrays.
Well, that last one does sound like something my cat would say, but it seems pretty cool.
It's like when I go camping and I plug in my camper van.
Yeah, well, getting your power set up is pretty important, especially if you're in space. You don't want to be going outside there without fully supported environment. But yeah, that's they say so many great things going on now, and this was only 2007, so I was just like, this is, it seems like yesterday, but I realize it's not.
No.
All right, so let's go ahead and take a moment, and I will just remind everybody that you are in fact listening to York Universe. broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you'd like to join in live with our crew, who are right now watching live images from the 1 meter telescope, you can go to yorku.ca/science/observatory and go to online public viewing OPV, or click on any of the links that say YouTube to go to the Allan Carswell YouTube channel, where we are live broadcasting with this audio and, of course, images from the 1 meter. Tonight you're listening to Dr. Elena Hyde and Julie Tomei, and we're discussing, I guess, launches and Mars and all kinds of great stuff. And of course, just a reminder, if you are listening to this live, please do think about heading on over and joining in the chat. Our crew of observatory students are there to answer your burning questions about astronomy. And of course, we finally have a clear night, so images are being shown. Very exciting times. All right, so let's go ahead and travel back, I suppose.
For Mars.
More Mars. So I got carried away when I saw this post from Julie earlier, and I couldn't help but make all of my items Mars missions. So that means that I'm going to tell you that in July 27th of 2021, which actually really wasn't that long ago, NASA announced the architecture for its Mars sample return campaign, which might seem a little bit odd because if you'll recall, I just told you that it was Mars 2020 that started the actual sample return, and Perseverance has been working on these. But the truth is, it wasn't a 100% agreement about how to get the samples off of Mars. So the architecture for the Mars sample return campaign is still ongoing, and it's still a topic of discussion, and there's a lot of fun news happening around it. So July 27th, 2021, we kind of got a bit of an update. And this is just a reminder that this is NASA's Mars Perseverance rover. What it's doing, in addition to all of its other cool stuff, is it's building a unique rock collection. So geologists, eat your heart out, I suppose, because Perseverance is over there collecting unique Mars rocks. This includes samples of Mars's atmosphere and loose surface material, as well as other kinds of interesting rocks. So they specifically grabbed samples of rock that would help record the history of the Jezero crater where it landed. And hopefully, they're hoping, obviously, that some of their samples might preserve signs of ancient life. We won't know, of course, until those samples are returned to Earth and they can be analyzed. But these precious samples are being prepared and kind of wrapped up on the surface of Mars with the idea that Mars sample return could deliver them to Earth for detailed study. So returning a carefully selected set of samples from Mars to Earth has been a major long-term goal of interplanetary exploration for a very, very long time. The first moon rocks that got sent back, and I'm 99% sure this was by the Soviet Union. The exact date is escaping me. This was a long time ago. We were able to do sample return from the moon, but Mars is another beast. It's much, much farther away, and it's got bigger gravity than the moon. So it's harder to get things off of the surface of Mars. We want to be able to look at these rocks in detail on Earth because our laboratories at the moment are still all much too bulky to be sent there on a rover. So data from past missions, and this is, everything up to date, which lots and lots of Mars missions have happened, we can confirm that Mars did once have somewhat habitable conditions. So early on in its history, a long, long time ago, as they say, billions of years ago, it would have had habitable conditions that were capable of supporting life as we know it. And this evidence is in the case of, water mostly, and that there would have been a warmer, wetter period about 3 billion years ago. And this was around the same time that early life was existing on Earth. Not human life, but early life on Earth. So if Mars got the same kind of early life as Earth did, Maybe it still has those organisms. Maybe they evolved in a different way. Maybe we could make some insights about the origin and evolution of life on Earth. So the Mars sample return, as you can imagine, is a big, big issue. And of course, we're just talking about the wonderful Mars tools that are all over everywhere. There's actually a Mars rock sample tracker on the Mars exploration site that you can follow. They show what kinds of samples have been taken. There have so far been 20 samples taken of the 38 that they plan to take. And you can select a sample and see how much atmosphere it has, how much rock core it has, and how much regolith it has. And each sample has a name, and they've got sol dates sealed, so the date that the sample was sealed up. And they have likely rock types. So they've tried to characterize the what it might be. So for example, one of the samples, number 17, has a likely rock type of mixed sedimentary and igneous grains, which, I mean, doesn't sound like much, but to a geologist, I'm sure this is very telling. It also comes with about 10% regolith and 5% atmosphere. So in the little sealed sample container, you get a bit of atmosphere from Mars directly to test, which will be hopefully much more accurate than just using our rovers to drive around. So the samples are stored, and of course they can be picked up and taken off of Mars if we had a way to get off of the surface of Mars. So a Mars surface lifter, or ascent vehicle, as they believe they're still calling it, the MAV, or Mars Ascent Vehicle. They're hoping that they'll be able to use 2 solid rocket motors and launch from the surface of Mars, off of Mars, back to Earth. This has got to be done remotely. They're hoping to do it with an entirely robotic crew, which, has its pluses and minuses, I suppose. But an entirely robotic crew would bring the samples back without the need for humans to go there. That said, there are humans trying to go there. So it's, I suppose, it's a little bit of a current space race to see which one will happen first. Will we get the samples back to Earth, or will someone get to Mars? I think the samples are going to end up being the easier way to go, because it does just involve robots, which don't need things like breathable air and gravity. Food, water, bathrooms, and coffee, obviously. The Mars Ascent Vehicle is the proposal at the moment, and of course, Mars sample return is pretty interesting stuff. So this is really kicked up just this year. If you've been following along a little bit on the timeline of the Perseverance rover, the first sample was earlier in 2023, and I have to remember what year it is. So yes, it is. I'll have it about right when we get to December, and then of course the year will change. Happens every year. No, but the Perseverance puts its samples onto the Martian surface, and from there they can easily be picked up and taken someplace if of course you have a vehicle capable of going to Mars and picking it up and getting back off of the surface. So what you actually have to do to make this happen is you have to transport a craft to Mars with enough fuel to then lift it and the sample off of the surface again. So this will be the first time that we've done this off of a more massive body. It has, as I say, been done for the moon a couple times. So I'm hopeful that's it's a technique, or a tried and true sort of technology. But we'll see. So it's similar to the lunar samples from the Apollo missions to the moon. We can all remember, or well, we can all read about, I suppose. I wasn't actually here for the Apollo missions, but I definitely can read about them. And the moon rocks that are still on Earth are so valuable and so studied. And we actually have talked before on the show about the the hilarity of trying to assign a monetary value to these rocks because they're priceless, because they're so rare. And similar to that, if we're able to get these Mars rocks back to Earth and study them properly, that would it's going to be generations of people are going to be very thoroughly entertained by this. Especially the geologists and the planetary scientists. But I think all of us will enjoy it. So let's go ahead and I'll wrap up my Mars sample return. We hope that it works. There is a plan for it, and it does involve NASA and ESA collaborating together. So fingers crossed that it works, I suppose. And you'll see if you go back and read, each sample sort of had its own little news announcement. So there's been 20 so far, and hopefully they finish up successfully and they all make it back to Earth.
I am so curious as to how these names were chosen.
How the sample names were chosen?
Yes.
Well, I believe some of them were from the region that they came in, right? So the area of Mars where the rover took the sample.
If you look at them and then you Google them, no.
Ah, okay. So I just assumed that the rock sample names had come from where they were. So sample number 20 is called Otis Peak.
Okay. So, but if you Google Otis Peak is in Colorado. Oh. Now Google is talking in the background. So if you Google each of the names of the samples, some of them correspond to places on Earth. I found one. What sample was it? 7? No. 8 is, and I'm butchering this pronunciation, I'm sure, because I don't speak Navajo. Honi, which apparently means perseverance in Navajo, which is kind of awesome.
So perhaps they've done some interesting naming convention. I would have thought that they would have been near what the feature name was, but actually, if you look at this, you're right. If you look at the samples, some of them are named after the feature. So sample number 1 is Rubion, and the feature name that it's next to is Rubion, but its location was Polygon Valley.
There's a place called Rubion in France.
So there's definitely some interesting
something happening here.
Something interesting happening with their names for sure. But the sample names don't go with the feature names, which do not match the sampling locations. So that is handy to know if you are trying to sort out where all of the samples have been taken. But there is also a map where you can just see on Mars where all the samples have been taken. So that's probably the way to go.
Okay. All right. That is a mystery for another day.
Exactly. Well, and when you get Mars sample material back on Earth, it answers so many questions because, of course, people are looking to go to Mars, and we'd like to know what kind of soil and rocks we will have to deal with when we get there. Are we going to be able to easily make bricks or some form of concrete or adobe, which is something that people have been proposing for Mars habitats for ages? And if you have
generate fuel to get back.
Well, and that's actually the atmosphere has been proposed to generate fuel, so the atmosphere samples will help with that.
Oh, and there's so little of it, though.
Only 5%. Well, we need all those samples. But yeah, it answers all kinds of human habitation questions if you can get those samples back on Earth. And I mean, obviously, if you're going to send people, you do want to try to understand the environment as much as you can beforehand, because it is another planet and it is not directly habitable for humans. Not without a lot of technological
So very
interference.
true.
Anyhow, we should. I suppose we should wander on to our news items for this evening.
Yes.
Now that we've gotten all interested in Mars and going there and rockets, there's a little bit of as you say, a little bit something different, which is pretty fun. Something for the archaeologists, the astronomers, and more.
Yes. Well, I can't resist a story that brings together astronomy and my day job at the museum. They're building a spaceport in the UK, in Scotland, in the Shetlands. Um, it's called the Saxavord Spaceport, and it's getting ready to start launching things later this year. It's on the northernmost island called Unst. And it is standard practice in the UK to document and dig when you're building new things because of just how dense the archaeological record is below ground. And there are companies that do this, and there are charities that monitor the excavations and that sort of thing. So there's like this whole infrastructure that exists in the UK for this sort of thing. So a company called AOC Archaeology was on site to document a protected radar station on site, and that radar station was from the Second World War. What they didn't expect to find was quartz, giant granite stones, and a possible cremation from the Bronze Age. And so the find was unexpected because there are no other Bronze Age sites in the immediate area. And the site stands apart because there's a circular zone of highly reflective and white quartz pebbles around it, evidence of cremation, i.e. burnt bones, filing cabinet-sized granite boulders that would need several people to move them over a short distance were also found. And the boulders were buried so only the tips were visible. Since the excavations are at early stages, it's not yet known if the cremations and the boulders being buried happened at the same time. So very loosely defined, the Bronze Age describes an evolving set of cultural beliefs and using mainly bronze for tools, generally living in roundhouses, clearing forests for livestock, and using either burrows or cremations for the dead. It happened at different times at different places, but in the UK, it's from roughly around 2,200 years BCE to 800 years BCE. There's not a lot of Bronze Age sites in what we now call Shetland, and the communities in that region that are known were quite distinct from one another. And while a great deal of Saxavord has been recorded, there's still some that's relatively untouched, so there's yet many more discoveries that may be made at the site. The excavations at the spaceport will help archaeologists learn about the Bronze Age there and in Shetland at large. And it will take at least a few more months to learn about the finds and to decide how to protect them. But the spaceport officials are committed to sharing the story in some way for visitors, maybe an exhibition or a marker or something like that. Time will tell.
Indeed. And of course, it's worth mentioning that time in astronomy is so strange because we're talking about billions of years ago on Mars, 3 billion years ago. Humans have such a hard time grasping things that are on the order of even hundreds of years old. And the Bronze Age story feels like ancient history. But as you say, it's 2000 BC or something?
2,200 BCE, yeah.
So
about 800 BCE.
So 2200 BCE would be 2023 plus 2000 or so. So we'll round up to 2000, but to get back to that period in time, something 4,000 years ago, right?
Roughly, yeah.
So if we're
like
talking
the blink of an eye.
Yeah, if we're talking the
astronomically speaking,
Bronze Age, it's a mere 4,000 years is nothing for Mars and Earth and dinosaurs and stars. It's so recent. Our closeness in time to this discovery, it's like we might as well say that we're building our this launch pad or spaceport, sorry, this spaceport on like our grandpa's backyard or something. It's so close in history, but it feels so far, just from our perspective, because it's of course in the Bronze Age technology was so different, but it's actually so close to us. It's kind of an interesting disconnect that you can get in archaeology and in astronomy. And this is I love the combination. So I agree with you. It's a great article.
It's I don't know. It's so neat.
Yeah,
you never know what you're going to find when you dig a hole in the ground.
Oh yeah, well, and it's so good that they are actually, being careful because, of course, the Bronze Age materials are not that plentiful, and it's so close in time, but we still don't have very good records of what people were doing and writing and reading and technology-wise in the Bronze Age. I mean, we have some idea, but not great records, obviously. So it's worth noting that when we're fiddling around trying to figure out what happened 3 billion years ago on Mars, right? We barely know what happened yesterday in the cosmos here on Earth, in the Bronze Age, just a mere 4,000 years ago, just basically yesterday. So if you've ever wondered why astronomers have trouble with time, this might be one of the reasons. All right, so I think we'll go ahead and wrap this episode up on that timely note here, and say thank you everybody for joining us this evening. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Julie Tomei and myself, Dr. Elena Hyde. Stay tuned because it is Science Night in Canada. Coming up next is Western Worlds, Quirks and Quarks, and Science for the People. Thank you everybody once again for joining us, and if you have any questions or want to see the OPV replay, head over to yorku.ca/science/observatory. Thanks for tuning in to York Universe. Clear skies and have a good night.
AFM original programs on our website. It's really easy to find us.